We straight move into our first panel discussion for the day. The session is titled Heat Rate and Flexibility Coal-Fired Generation Units. The session will focus on heat rate improvement guidelines for the Indian power plants, how to reduce CO2 emissions per kilowatt per hour of electricity produced by improved efficiency of the coal-fired thermal plants, reducing net heat rate of the power plants, and a lot more. I would now invite our moderator for this session, Mr. Prabhat Verma, Managing Director, Runpa, India. Mr. Verma has over 30 years of global business operation experience with companies like ABB, Honeywell, Delta, and Doosan. He has executed multi-million US dollar projects in the power and oil and gas sectors, both in India and abroad. He holds strong relationships with business stakeholders, policymakers, government bureaucracy, PSU, and project owners. Mentored many unicorn startups while in association with IIT Madras for fundraising and product development. He has worked with USAID, KFW, GTZ, Zyka, J. Cole, World Bank, and many bilateral cooperation funded projects successfully. He also works closely with NGOs, consultancy organizations for promoting environmental and clean energy solutions. As a technology enthusiast, he has mentored futuristic technology solutions for developing, bringing, implementing new technologies for renewable energy and clean environment. I would now also invite our panelists who would be joining Mr. Verma for this session. Request you to turn on your videos as I call you out. Please welcome Mr. Kamal Kishore Mundhada, partner and trainer, thermal power, ex-NTPC. Mr. Mundhada has 41 plus years of experience and with reputed power major, NTPC Limited, and major original equipment manufacturer service providers in all spectrum of O&M in India's best operating coal and gas power plants. He has been instrumental in implementing the world's best power plant practices and systems for performance enhancement. He has supported Chinese supercritical and BHEL make subcritical power plants managed by STEAG Energy. He has also conducted various online training programs on advanced operation and maintenance of supercritical power plants and has been actively engaged in skill imparting in emerging power scenarios like power plant flexibilization. Also, please welcome Mr. Anjan Kumar Sinha, Technical Director, Power Generation Industry Services, Intertek Engineering Consulting. Mr. Sinha is a power plant specialist with 33 years of experience in operations, maintenance, commissioning, and renovation and modernization of large thermal power plants. He has prepared concept papers on power sector reforms and evaluated studies of international consultants on policy and regulatory options. He has been responsible for carrying out training programs for government agencies and policymakers as a member of special task force and national committees. He has successfully managed the complete power business operations of Vedanta Jharsuguda, provided expert operations to government multilateral agencies like USAID and policymakers on power sector reforms. He has also performed collaborative research with organizations, consultancy firms, and original equipment manufacturers. We will have Mr. Kamal Kishore Mundhada make his presentation first, followed by Mr. Anjan Kumar Sinha. Each panel member will have 20 to 25 minutes and an additional 10 minutes with the moderator for a discussion post their presentation. Requesting our moderator for this session, Mr. Prabhat Verma, to please take this session forward. Over to you, sir.
Thank you, Shriyal. It is my honor today to have two stalwart of the power sector, Mr. Kamal Kishore and Mr. Anjan Sinha. And the topic is very apt, flexibilization. It is, a very important topic today because a lot of RE implementation is happening. And definitely renewables are given the first preference. First, preference, it must run. So coal-based power plants are going to be a supportive role. As and when renewables are not available, they have to come on grid and ensure that power is made available to everyone. I mean, as it is our initiative, power to all 24/7 into 365 days. So flexible operation of the power plant is the subject which is being discussed globally. And Mr. Kamal Kishore and Mr. Sinha is part of the global initiative, in fact, because of their association with various international organizations. So flexible operation of a power plant is I think it's a very important topic. Power plant must flex because coal-based power plant takes a lot of time to start and stop, and which goes up to 10 hours. And we have a huge capacity which is installed, both subcritical and supercritical. So it's a challenge. But every asset which is there, whether it is subcritical or supercritical, must be utilized properly. There is a CA report also which says that all kind of power generation must coexist. And then there is the IT system which can bring all kind of power generation on the grid, and probably we get the power at the lowest possible price. So flexible operation is a need as an ancillary unit also, as well as every power plant should be capable of flexing. So it is a great session going to be. It's an opportunity for me to listen to both the senior colleague of mine who have a rich experience from the power sector. So I will not take much time because there are participants who are waiting to listen on this subject. So I will first invite Mr. Kamal Kishore to make his presentation. And then at the end of his presentation, we will have some question answer. I will also have some questions. So over to you, sir, Mr. Kamal Kishore.
Thank you, Vermaji, and good afternoon, good morning to my dear colleague, Mr. Anjan Sinha, and all the colleagues from the power generating companies.
Sir, we have received your presentation. Would you be sharing screen from your end, or you would like us to do it for you?
I would like to share from my end.
Sure. I will just give you the access. Yes, I've given you access. You could go to the share screen option at the bottom of the screen and share the presentation. You could go to the slideshow mode. Yes.
Is it visible?
Yes, it is.
Okay. So once again, good mornings to all my colleagues. As Mr. Prabhat Vermaji has rightly pointed out that our Indian's power scenario, particularly power generating company scenarios, is at the cusp of the transformation. And we have a commitment for climate change, and for this commitment, we are adding at a rapid pace renewable power, particularly the solar and the wind power. And as this power is a not allowable 24/7 round the clock, so and also as our gas resources and our hydro resources are limited, and still the storage at the commercial scale has to emerge. So brunt of this capacity addition on a renewable is need to be bared by the coal power plant. And this is here is the role of the flexible operation of the coal power plant. And coal power plant flexible power operation has a two aspects. One is a technical aspect and another is a commercial aspect, and we will discuss both the aspects. So my presentation will contain the country's present and the future power scenario. We will start with the brief of that, and then we'll see what is urgency and trigger for the coal power plant flexible operation. Then we will discuss some of the concept and challenges of a flexible operation. And as a prerequisite, already country has undergone some of the test run, trial run at some of the power plant, and we have some of the case study. So we will see major observations and recommendations from this case study. And then we will see in a short what is the way forward for flexibilization. And ultimately, lastly, we will see what are the on the commercial aspect, what are the heat trade measures we can take for power plant flexible operation. So if you see the India's present power scenario, we can see that presently installed capacity is a 408 gigawatt, out of which bulk of the capacity is still the coal plant, which is 210 gigawatt, which is almost 51.5% of a present installed capacity. But when we see this capacity from a generation point of view, then this renewable, particularly the wind and solar, comes to the almost 12% figure, which is the actual figure of September of this year. But this, even the 12% figure are very significant, because this power from renewable is not available round the clock. For a very limited period of a day, of a season, or a year, this power is available. So this figure is a very, very significant figure. And at present also. And if we see the water, we know that the renewable power energy addition is important from our climate commitment, as well as this power is also a relatively cheap power. But there are some challenges associated with this power. One biggest challenge is this power is seasonal power, and there is over a period of a day and season it vary. And if we know that the solar power vary during a day, but it peaks around noon, whereas wind power peaks around the midnight. So there is a mismatch with a grid requirement of a conventional morning and evening peak load, and this almost again this power we don't have a much control. So we are facing some level of flexibilization still under present conditions. And for this, there are some certain norms for which are invoked at present. And if you see the present norm of flexible operation, then central station, particularly the NTPC, they are reducing the load, the minimum load, to the 55%, whereas for state and stage station, it is almost 60% to 70%. And there is some compensation for heat rate, APC, specific oil consumption, and the ramp rate. And if we extrapolate this scenario for future, then we know that due to the climatic change commitment, we are having a world's largest RE energy expansion plan, that is a 500 gigawatt till 2030, with a share of non-fossil fuel of 50%. What will be the future scenario? Future scenario is provided by the CA in his draft national electricity plan, and as per them, by the year 2026-27, our country's peak demand requirement will be 272 gigawatt, and to meet this demand, we shall require a total installed capacity of 623 gigawatt, with a share of almost 265 gigawatt of a thermal, and the renewable 332 gigawatt. So here you can see the RE capacity surpassing the thermal capacity. And if you see the requirement by 2031-32, the peak power required will be 363 gigawatt, and for that installed capacity requirement will be 866 gigawatt. And here the thermal capacity will be increased to the 274, which will be the 31.6% only of a total installed capacity, while there will be big jump in RE capacity, and it will almost goes to the 569.4 gigawatt. And but still, one thing interesting is to note that still the battery storage will be commercially available, is expected to be commercially available post the 2026-27. And still there is a apprehension that this power will be costly. So And since it is for coal plant flexibilization is seems to be best option in the power scenario to accommodate the RE at a economical price. This graph was projected for this year some year back, when it was assumed that we will add 175 gigawatt by the year 22. But still, since there was some slag in the capacity addition, but still it is very, very relevant that in near future, this condition will come when we're meeting a demand of a 171 to 190 gigawatt in a day. Then we will have a peak of almost 108 gigawatt or so from our renewable power. And to accommodate this power in the grid, our coal plant need to back down to the level of 1/3. So this is the emerging scenario, and this is the emergency. This is the urgency of understanding the flexible operation for a coal plant. So realizing this scenario in the near future, CA has come out with some draft notification, which is still in draft form, and final notification is expected this month with some fine tuning. But as per this draft location, load dispatch center shall schedule all the coal plant at a minimum load of 55% within 1 year. Please note, presently, other than NTPC plant, most of the plants are operating at a minimum load beyond this level. And the ramp rate required shall be 3% per minute above the minimum load, and against a present of nearly 1%. And for supercritical, it will be 5% per minute. But after the 3 year, the load dispatch center will schedule all the power plant to a minimum possible load of 40%, subjected to they have undergone some modification. But this modification are further subjected to the technical feasibility studies in consideration with either the OEMs or for some qualified consultant. And so the final notification is expected next month, even with because some consultation is going on among the different stakeholders, and expected that with some fine tuning, the almost 55% and 40% minimum loading shall remain. So we need to realize that these flexibilization norms for minimum loading as well as the ramp rate are stringent, and they are time bound too. So we need to have some prompt action. So there are, let us now define the flexibilization. So there are many definitions of a flexibilization. Even one is provided by EPRI. But if you want to see the flexibilization in practical sense, then we can say that during the load variation in the power plant, extent to which the coal generation can be increased, reduced reliably and repeatedly for few minutes to several hours at a faster rate and speedy startup when required. Here are few important words. Extent to generation, extent to which coal generation can be increased or reduced, that is finding a minimum load. Again, it will be a reliable should be a reliable operation. Again, it should be can be a repeated process, and it can for a few minutes to several hours and at a faster rate, and startup time also is now matter. So when we see the flexible operation, there are three attributes of the flexible operation. One is minimum possible load, another is a faster ramp rate, And third can be a unit startup or shutdown time. So we can say that this uh, uh, present era of a coal plant operation, this era is a very stringent. So we require a rethinking on a coal power plant operation philosophy. So if we further break down our attributes in the requirement of a flexible operation, then we can find the 7 requirement. One first is the stable operation at a particularly at a minimum unit minimum load. And then since we are varying the generation, there should be a unit reliability at a wide load variation. And this ramp rate up and down must be at a faster rate. There will be a higher startup, shutdown, and the load cycle. And then we will need to have a start, shutdown time and cost reduction measures. And again, this flexible operation will cause some problem with a environment norms. So for meeting the stringent environment norm will be essential. And last but not the least is a cost-effective flexible operation. So let us understand what can be impact of a flexible operation. So as we know that impact of a flexible operation will be the more frequent load changes due to the cyclic operation, more frequent minimum load operation, faster load ramping and causing the thermal stresses, more startup, and reduce ultimately due to the partner operation, reduce the plant efficiency. And due to this impact of a flexible operation, there may be a likely to be some long-term damage. And it is feared that it will lead to the increase in the equipment breakdown. It will lead to the mechanical failure, particularly due to the creep and fatigue. It will lead to the stresses failure like boiler thick wall component. It will increase in the boiler tube leakage. It can increase in the thermal shocks, particularly economizer and superheater header. It can lead to the fatigue failures, particularly in turbine rotor, due to the cyclic operation, and and there can be a dissolved gases infiltration in the boiler, causing the corrosion. And there can be a possibility of oxide scale carryover in a turbine blade erosion, and all this will lead to the consuming the life of a plant component, and it will lead to the lower residual life and high R&M cost. So since last 4 and 5 years, the number of feasibility study, flexibility study and tests were carried out at the NTPC plants and other plants like NTPC Dadri, Mundhada, Gujarat electricity, Ukai plant, Methane plant, Andal plant. And purpose of the study was to identify the process and control system limitation for a flexible operation. And second was to identification of retrofit for the plant which are required and which are techno-commercial possible for flexible operation. And in all such study and tests, it was successfully demonstrated on a 500 megawatt unit minimum load operation at a 40% load, that is 200 megawatt. And even the ramp rate of 1% and 3% was achieved. So if you see what are the major observations during this flexible operation case studies. So the load reduction steps were in the 5 steps: 420 megawatt, 330 megawatt, 280 megawatt, 230 megawatt, and 200 megawatt. And almost at each stage, control loop were fine-tuned at an intermediate load, and minimum load of 40% was run with a minimum 3 coal mill operation, and the sliding pressure mode was fine-tuned to avoid the uh, steaming in the economizer, and the HRE steam temperature was found to be maintaining low, and there was some disturbance in the feed water and drum level as the BFP resolution wall was for the on and off type and not of a moderating type. And it was founded again at a minimum load. The coal flow variation is there among the coal pipe, and again the flame intensity variation was found at a load fluctuation. And again, it was a part load operation. At a minimum load operation, it was found that the flue gas temperature was below the acid dew point. So as after the detailed deliberation, the flexible trial run of flexibilization, there was a recommendation for sustained flexible operation on the software as well as the hardware. For the software, there was a need of a CMC fine-tuning, including the subloop, as most of the power plant are designed for a base load operation. So when we want to go to a lower load, so this CMC fine-tuning is including the subloop fine-tuning is required. Another need was felt for a mill scheduler, so that mill can be taken on and off on auto. Online coal analyzer for control and monitoring was felt, as our Indian coal is of a poor quality. Moreover, we are using a multiple sources of a coal in most of the power plant. Again, auto start of the unit, fans and the pump was suggested, and moderating type BFP resolution wall and boiler protection healthiness at low load operation was suggested. And optionally, it was suggested that online coal flow measurement through the each pole pipe and turbine blade vibration monitoring was suggested. As far as hardware upgradation is concerned, startup related temperature measurement need to be looked into for their integrity, and evaluation of a current hardware for the particularly for flame detection was need to be upgraded, and dynamic balancing of the coal flow is also felt, as there is a variation among the coal pipe of same mill coal pipe during the part load operation. And as the assessment of the long-term impact is very, very important, so it is suggested for the finite element method analysis, online condition monitoring system, thermal feasibility study, and final boiler fatigue monitoring system. So enhancement of the control, monitoring, and the diagnosis system for sustained flexibilized operation is a recommendation. So now next question comes, from where to begin, how to achieve the flexible operation. So first and foremost is understanding the need of the flexible operation. Need to be awareness need to be created among all our operation and maintenance staff, and proper training is need to be provided before going forward. Second important step is analysis of the status of a present unit by using the historical data, best practice we are following, and best practice followed by other power plant, and what procedure mode optimization we can do. Particularly here, the boiler combustion stability and control loop response at a load of variation and minimum load are very, very important. Then we need to go for a test run by under the strict supervision for a minimum load operation, startup test, and cyclic run at a faster rate. And this after conducting the test, the analysis of this plant performance during the test need to be made, and we need to identify what are the bottlenecks if we go for a flexible operation repeatedly. And then this impact evaluation on a plant O&M for a long term, we need to assess. Then we need to see what we need to identify the measures for a flexible enhancement based on the cost benefit analysis. And then we need to develop a action plan to achieve the flexible operation on a repeated basis. And finally, we need to go for implementation of a selected measures. So first and foremost, as I have told, that revisiting the O&M practices for minimizing the cycle damage is a must. So we need to see how we can modify some of the startup and the shutdown and ramping procedure to lower the component fatigue stresses. How we can make judicious use of HPLP bypass as done in some of the European countries. And we need to adopt some of the advanced chemistry monitoring system. Again, as due to the cyclic operation, we need to revisit our maintenance philosophy around the extent of a cyclic component. Again, operation stop need to be given a free and judiciously taking the oil support for short duration as we are facing a poor quality of coal. And again, we need to relook for our plant preservation procedure as we may have to shut down our unit frequently. As far as the unit startup time optimization is concerned, there are some measures we can take. First and foremost, we need to monitor closely each our startup, and we need to do a gap analysis for time taken to achieve each milestone of unit startup. And we need to evaluate this with respect to the OEM norms and best achieved so far by us. Again, taking the escape into service, irrespective of the weather, is recommended to get a preheated secondary air and the primary air. Again, the deaerator pegging is a must to provide the preheated feed water to the boiler, and it will both the escape and the deaerator will shorten the startup time to some extent. And again, there always a dilemma for taking a first mill in service, because when we take a first mill in service, we need to ensure that our HPLP bypass charge remain charged to protect our reheater, and there must be sufficient flue gas temperature at economizer outlet. And so how we can speed up taking with the first mill is very, very important. And again, the automatic unit startup to overcome the operator dilemma is very, very important. We need to ensure the startup related temperature transmitter integrity, and we need to replace that faulty one, and we need to optimize the set point without compromising the unit safety. So till now, we have seen the technical aspects of a flexibilization. So we know that due to the flexible operation, we need to do a part load operation and at a minimum load operation. And our heat rate, which is a measure of a unit efficiency, will be measure sufferer. Here we can see that for a even 500 megawatt unit or 800 megawatt unit, if you are run at a 40% load, then there is a increase in heat rate of a 14% and 16% respectively. Moreover, unit flexible operation possesses the high percentage auxiliary power consumption, and measure need to be taken to find out the contain the deterioration in the heat rate. So first, when we talk about the flexibilization and even the heat rate measures, the first thing come into mind is a boiler combustion optimization. Because boiler combustion optimization is key requirement for unit stable operation at a minimum load operation, as well as for the load variation, and also it is a requirement for maintaining the boiler efficiency. So how to look for a boiler combustion optimization? We need, since we are firing now in most of the plant multiple type sources of a coal, so understanding the coal characteristics and their coal constraint particularly the VM and the moisture is very, very important. We need to fine tune our SCDC operation continuously as per the fuel and the unit load. Since excess air play a major role in the boiler efficiency and the boiler stability, so we need to have some offline grid measurement at a particular frequency. Moreover, the CO monitoring online will guide us a better combustion optimization. Coal mill optimization is a very vital role in a combustion optimization, particularly if you can attain a better coal fineness, we can attain a mill outlet temperature as permissible by the fuel. If we can optimize the PF flow through the mill, and if we can get the uniform coal air distribution, then we can get a better boiler combustion. Unburned carbon monitoring is very, very vital, because this is a reflection of a poor combustion, and monitoring and addressing the issue will help us in achieving the boiler combustion. Flue gas temperature and the excess of O2 stabilification give us an idea of a problem in the boiler. So addressing them is a very, very important. And the reliable flame scanner for combustion assessment is also required. So stable and complete combustion in each unit load condition is a key enabler for sustained flexibilization and boiler efficiency. Another important thing is a coal mill, number of coal mill optimization. As we know that if you are running the machine at a part load, particularly at a minimum load like a 50, lesser than the 55% or up to the 40%, then if you are running more number of mill, then our PF flow increases and we are compromising on our secondary air flow and the windbag pressure. So which lead to the sometimes the flame problem of flame stability, and mostly it lead to the insufficient boiler operation. So reducing the unit to a minimum load is very, very important. There may be hesitation on a part of a boiler operation engineer to reduce the mill, but they need to be educated, they need to be trained to take this decision. Again, the superheater and reheater temperatures maintaining is very, very vital. So here two measures, that is using the top burner during the part load operations, and the judiciously operation of a burner tilt is very, very important. Again, it was found that the sliding pressure operation give us a better heat rate, and here we can see that there is a 50% 50 kilocalorie improvement in a sliding pressure operation. So this need to be taken care. But this may be need to do some fine tune to avoid the other problems. When we talk about the net heat rate, then the minimizing the unit auxiliary consumption is a very, very vital. And it is again, it says that the single stream auxiliary operation, particularly the single ID fan, FD fan, PF fan, CEP, BFP, and minimum number of mills are very, very important, particularly when we are running the machine below 50%. And hesitation on part of a boiler operation stop to come to the bare minimum number of coal mill. This is required from point of a boiler stability as well as reducing the auxiliary power consumption. Again, when we go for a sliding pressure operation, then it reduces the BFP auxiliary power consumption. So it also helps in a reduction in auxiliary power. And provision of the VFD on auxiliary as per the cost benefit analysis is a must. So single stream auxiliary operation is must to contain the net heat rate deterioration, but auxiliary reliability is key issue for efficiency management at a part load operation. Operation staff must have a assurance of a auxiliary reliability. So at the end, we can conclude that the rapid growth of a renewable necessitates the coal plant flexible operation, control loop fine-tuning, boiler combustion optimization, and O&M practice modification are prerequisite for a coal plant flexible operation, and well-calibrated trial run for flexible operation are core to the achieving the flexibilization. And we need to explore the suitable retrofitting options on case-to-case basis for each station on technical combustion study, and heat rate improvement measures such as a combustion optimization, superheater and radiator temperature control, sliding pressure operation are vital for sustainable technical commercial flexible operation. Finally, we can conclude that the coal plant flexible option with the stringent norm need to be understood, deliberated, and appropriate action to be taken, to appropriate measures to be taken up to be implemented along with the measure to contain the heat rate iteration. That's all. Thanks a lot for present hearing.
Thanks a lot. No. You see, now I'm just listening. I just minimize that. I'm able to hear.
Thank you, sir, for your great presentation.
How to increase this?
You have put all your experience in these slides, and I think it is going to be very, very, very beneficial to the power sector. Shriyal, we can have questions now. I think we can ask few questions.
Yes, I would request the attendees to please use the Q&A box at the bottom of your screen and to key in your questions for us that we could take up with Mr. Mundhada. Mr. Mundhada, I request you to even stop your share screen.
I made this. Then how do you do?
And yeah, while we don't have questions coming in yet, but while they would come in, Mr. Verma, if you have any questions, you can go with that.
Shriyal, I have some questions, right?
Sure, please.
Because flexibilization is a subject which is
one more
probably.
I'm sorry to interrupt you, Mr. Verma, but can I request all the other panelists to please go on mute?
Yeah, okay.
Also, yeah, okay, please continue, Mr. Verma.
Kamal Kishore sir,
Yes, sir.
flexibilization is a subject which is being discussed widely, both by Indian agencies and internationally. And I feel it's a topic as we discussed is very relevant and important. But I feel that running the plants in a flexible operation, because these plants are never designed, and by virtue of its characteristic, it is not designed for ramping up and ramping down so fast and frequently. And as you shared that the ramp rate should be 3%. And even if you talk about technical minimum, just now you said that the CA is thinking about asking everybody, our load dispatch center, to be at 55%. So maintaining the flame at the low load is a challenge because these boilers are never designed. So my questions are I have two questions. One is the question which is about our existing installed base. We have two types of boilers: subcritical with the drum and supercritical. So as per your experience and knowledge, which boiler, if we have to pick and choose, are the best suited one for flexible operation, ensuring there are not much failures, and most of the parameters are kept in control. So this is my first question: which boiler is more suited for flexible operation?
Sir, flexibility is a need of the hour. Now we cannot avoid the flexible operation. So, and one more thing is clear that this flexibility is to be bear by the coal plant only. So there is no escape from that. So as far as our experience is concerned, now CA will come with the final notification. He is expected to take some of the further corrective measures, they then provided in the draft, and it may be come out some very clearly. But as far as specifically from a point of view of the unit capacity, we know that our supercritical plants are capable, are even running at a 40% load, and some of the OEMs are claiming even running at a 30% load. Basically, Benson point is coming about the 30% load or 40% load. So they are capable of running the due to flexibilization, uh, uh, to go for a flexibilization. As far as the 500 megawatt sets are concerned, most of the all the trial operations were conducted on the 500 megawatt sets, and with some measures, additional measures, this is possible in a 500 megawatt. But for a sustained operation, we need to take some of the extra measures for repeatability as well as for impact, avoiding some long-term impact. And below the 500 megawatts, things will emerge over a time, I think, because whoever is responsible at a country level, they are of a opinion, I think, that machines which are able to flexibilize, they will flexibilize, and other unit will be need to either go for a two-shift operation or for a shutdown for a long duration.
Okay, all right. So, sir, you said that 500 megawatt has been tested for flexible operation. And I am sure government through notification will be giving probably more tariff to these plants which are flexing. Because if it is on the same PPA, probably the business plan will go haywire and it will not be workable. But when I see this 500 megawatt plant, even if they are paid higher tariff for flexing and acting as an ancillary service, I see the coal consumption and the CO2 emission is probably not really coming down in the same ratio of load. So how are we going to control? And these plants, again, it is something not relevant to the topic, but then there are many FGDs which are going to be, implemented in these plants. So your views as an expert of the power sector, having such a rich experience with NTPC, ONM, is such plant require FGD? That is question number one. Number two, are these plants going to be a good business plan with profitability?
Sir, coal is going to run for at least for 2 decades. There is no doubt about that. Okay, as per our assumptions, coal is going to stay for at least for 2 more decades minimum.
Not 2 decades. In fact, if you see the projection by NTPC, I was seeing, not NTPC, by CEA, it is going to be 15% coal-based capacity even by 2070 also. So coal is going to be there. That is for sure.
Yeah, at least for 2 decades there is no problem.
Okay.
At least
okay.
I always emphasize.
Okay.
And again, the flexible operation will be on a for a certain duration. And some of the power plant are facing the flexible operation. Some of the power plant may not face a problem flexible operation. Some of the power plant may need to go for a longer shutdown. Some of the power plant may need to do for a two-shift operation. So with over a time, the strategy will emerge on that. And as far as the FGD is concerned, so there is a strong stringent requirement from ministry. So there is no scam from that. So we need to provide a strategy FGD if you want to run the power plant beyond 2025.
All right. All right, sir.
And all the other commercial aspect expected to be taken care by the CERC.
All right. Thank you so much. Any question in the chat box? Let me see.
Yes, we have questions in the Q&A box, Mr. Verma, if you would like to just refer to it.
Right. I think one question, which is beneficial, just a minute. There are Which is beneficial, MDBFP or TDBFP at low loads? Sir, question for you.
Sir, when we are running a machine, first thing, we don't want to change over our equipment very frequently. So this is need to be kept in mind. So even the TDBFP may not be maintaining a TDBFP a little difficult at 40% load. But my experience of operation, I can tell you that as far as possible, the changeover in a very rapid up and down scenario will not be a good choice.
So you are saying that for preparing, if suppose, as we discussed, that many power plants are going to be labeled as a ancillary units and plant which is going to flex. So according to you, when we do the preparations, we need not to be replacing the turbine BFP. We should retain the same motor BFP. This is your recommendation.
Sir, almost whenever the TDBFP are provided, normally configuration is that there is one MDBFP plus 2 TDBFP. So this is normally a configuration. So there need not to install additional MDBFP because already there is already one MDBFP in place.
Okay. But I think this question is very important. Thanks for asking, Mr. Narayanan N. Are you satisfied with the answer, or you want some more?
Barmaji, Barmaji, may I add something to it?
Please go ahead, sir.
We had done various test runs. 12 of the test runs, I was part of that.
Right.
So as per the experience, we were not required to take MDBFP. We did everything on TDBFP, even at 40%. Latest was DVC and DAL, where we tested. There also we had TDBFP. Only we were required to change the source. So we ran on 32% minimum load. It's only when you do fast ramping at 3% and all, there it creates a problem. And the problem is with the recirculation valve. So in NTPC stations, it was all changed from full open, full close to control valve type. Because when the recirculation valve opens suddenly, whether it is MDBFP or TDBFP, it doesn't matter. But recirculation valve fast, like opening, closing, that creates a problem in the feed water flow. So that is the only modification that was suggested, and it was carried out in many of the NTPC stations. Otherwise, it's always better to keep TDBFP. No need to have this additional MDBFP and it's thought, because you start up the unit today, people are starting the units with TDBFP. Even you start up it from auxiliary steam source, but there may be some configurations when there is only single unit. There it can be a problem. There you need MDBFP. But when there are multiple units on source and there is a common auxiliary header, then you will have this adequate steam supply for this driving steam.
Okay. Thank you, sir. Thank you for your intervention and given the guidelines to us. Now, Narayanan, I think you are satisfied with the answer. What is given by both the experts. Now the question number 2. Now question number 2 is from Sachin Alaspurkar. He is asking, presently due to DSM mechanism, power generating units have to opt for flexible operation, which results in heat rate deviation. So how can we overcome their losses with the flexible operation? Mr. Kamal Kishore, sir, you answer this first, and then I will request Mr. Sinha to add some points to it.
Sir, since we are flexibilization up to the 55% as are now, so there is some norms are provided by CRC, and for further flexibilization below that, CRC has to come out with some more norms for heat rate, specific oil consumption, and auxiliary power consumption. So how much they compensate for that, this need to be seen.
But how much deviation you see, sir? I mean, suppose heat rate, if it is a 600 megawatt unit and the heat rate is around 2050, I'm talking about the station heat rate. How much deviation you see the variation? How much percentage? How much money CERC should give to meet the business plans?
As I have presented in one of my slides, so for 500 megawatt or 660 megawatt, you can see there was a heated deviation of 14% when we are running the machine at a 40% minimum load. And for a 800 megawatt set, it goes up to the 16% when we are running at a 40% load.
Okay. Sinha Sahab, anything you want to add to it? Mrs. Sinha, can you hear me?
Yeah, I was muted. Yeah. What I could understand from the question was like how to take care of the deviations in the heat rate on when you are operating on DSM. Am I correct?
Yeah, you are right.
See, one first is like DSM is inadvertent, and it's only the quantum is not that much. Only when the quantum you have to be within 12%, not more than that,
Okay.
and you make small load followings. That will not affect much. So DSM won't have much on heat rate unless you are doing a very significant load following, or you are going down. It's only like you are just increasing or decreasing to manage this grid. Only when you are on a consistent basis on a very low load, then only your heat rate gets affected. Even your primary response, but it's very low, 5% at the most. That is there, and that is part of the system.
All right. Okay.
And there are other means. I'll tell you there are other means because Dadri has implemented condensate throttling. I remember when I was there, we implemented it.
Right.
There, things are done without any loss in heat rate. You get a very good ramp rate without any parameter deviation, and the ramp rate that we achieved was 7%. So that would be a very good option for say DSM, for your AGC, even for your primary response. Okay. So there are technologies available, there are systems available.
Okay.
Okay.
But I think we are yet to have the final policy from CA or CERC or MOP.
Yeah, we are working on that. I'll cover that. Yeah. I got it. I covered that. See, we have been pushing with the regulators, with CRC. I have made around 6 to 7 presentations on the cost on incentivization. Because this is one thing which when we had started, I was advocating for proper incentivization model. So in NTPC, we got this compensation for heat rate till 55%. But there are a lot of other parameters like your O&M, your life consumption. So that part we are pushing, and recently, 15 days back, there was a meeting chaired by Power Secretary where he was convinced and he's asking the utilities for the numbers, what I should compensate. But unfortunately, people are not able to give these numbers. When you ask that what I should compensate, that is the irony. Means what is your life consumption? People are not knowing it, and there are very few competent people to do that analysis, to tell you honestly.
Yeah, that's very true.
In NTPC, we had struggled. We had engaged international consultants. There also we had engaged NG Laborolec, then Intertek, and Aptech actually used to do it. That was the only one who can do actual cost analysis. They do it for all the US utilities, and the regulator uses that number. But apart from that, it's a very vague, like people, compensate 3%, 5%, but exact numbers, it's a bit complex.
Sir, but don't you think such plants which are going to flex or acting as a ancillary service should be kept out of the purview of PPA? Let them sell their power through exchanges on opportunity-based costing.
See, to tell you, we had in the CA in 2018-19, there was a committee. We had categorized units on all India each and every unit we categorize on which mode it should operate on certain criteria. And then ideally there should be a market mechanism. Actually, I didn't have this in my presentation because this was with respect to heat rate. So I prepared this, but I have a lot of information on what are the internationally what is happening, what are people doing to compensate for this, what are the market mechanisms. Like everywhere, Europe has a market for balancing power. California ISO, they have market mechanism to compensate as well as incentivize all those flexible operation, different products, low load operation, even ramp rate, they have a staircase function. So by which they compensate. India, we don't have. So ideally, it is the market mechanism. Like see, in Europe, you have negative pricing. That is a mode of compensating. Means you pay the consumers to keep your machines running. Otherwise, it will be much more costlier to stop units and start up again. So this is a market mechanism. So that is the ideal case. But again, market has its own flaw. So it has to be guided. We have to move ahead gradually. And that is what we are doing in the Indian context. You know, if you depend wholly on the market, Europe today, you must be well aware of that. Where are the energy prices? So, but these mechanisms are gradually pushed in the Indian system, and CRC or policymakers, they are very proactive. We are moving ahead definitely. But all the stakeholders, they need to be involved. Nobody is doing original studies. Nobody even is ready to invest. They don't know what is the benefit. It can be many-fold, 100 times. But you need to start with small investment to find out, like even what is your cost.
All right.
So that also people are not able to tell the numbers. This is the reality. I'll tell you one thing. We talk a lot about combustion optimization. Recently, I had seen that there is no single party who can do a dynamic combustion tuning in India, unfortunately. EPRI did it. NTPC, there was a department called SENPIP. It was all handheld by EPRI under USAID program. But today, even NTPC has lost it all. All the people have been transferred, and today when you ask NTPC, I don't think maybe Ramagundam is doing it. But people, they don't have other instruments also. They're not working. But NTPC got a lot of gain in terms of heat rate under PSD program. But that is needed. See, the crux is it's not control and instrumentation and other things. Crux is your combustion optimization. I'll cover in my presentation.
All right, sir. So what we will do is, there are two more questions. I will take it up after Mr. Sinha's presentation is over, because I would request both Mr. Sinha and Mr. Kamal Kishore to answer these questions, because they have a rich experience and it's an opportunity for us to learn. So I will request Mr. Sinha to go ahead with your presentation now. Please, over to you.
Yeah. So can I share my, do I have the permission?
Yes, you do. Yes, you do.
Yeah, I'll share it. Okay. Just a minute. I'm trying to share.
You have the share screen option at the bottom of your screen, and you can just open your PPT first.
Yeah, I opened my PPT.
Then you can click on the share screen button. It's a green color button with an upward arrow at the bottom of your screen.
Yeah, it's shared, but the entire screen option is coming. Windows, and then
You should see your PPT also, which you have opened.
yeah, I'm not able to see somehow. Yeah,
Is it
just a
saved
minute,
on your
just
desktop? Then you can just do share screen.
Yeah, it's saved on my desktop only.
Yeah, so you can go to share screen windows and try to open it on your desktop.
Just a minute, share screen. I'll close all my other screens, I think.
Mr. Sinha, if required, you can also like just share your presentation with us. We can share it from our end.
Yeah, I don't have this.
Okay,
Just a
yes,
minute.
you're sharing screen now.
Yeah, yeah. Is it audible? Is it visible
Yes,
now?
can you go to the slideshow mode, please?
Yeah.
Perfect.
So yeah. So okay. Good morning. Yeah, these are some of the things that I'll cover, and the context would be heat rate, flexibility, what flexibilization has, how it will affect the heat rate, and what we need to do on heat rate while we are flexibilizing these units. I'll cover briefly on the cost impacts, part load efficiency, redesigning tariff. Just a introduction about my company. I'm in Intertek. Intertek is a company founded in 1978. Actually, earlier it was AppTech, and this company it has a rich heritage. This company was originally founded by Sir Thomas Edison long back, and today we operate in 109 countries with a employee strength of 46,000, and we have number of research labs. We partner with various research organizations. We are a major partner of EPRI, and then we work on various things like from asset integrity to we are the leaders in cost of cycling. And I think today we are the only one who provide this actual numbers on cost of cycling. So just a brief, like today, coal with a capacity of 51.6%, we generate more than 70%. The 74% number is coal plus gas. Gas is very low. So this just to tell you that coal is the mainstay of power generation in India, and it will be. Even by 2030, it is projected that 50% of our generation will come from coal. So entire thing will be dependent on coal in India, in Indian context, whatever you talk about, because we have lack of other resources, gas that could have been a better option for flexible operation. Hydro, most of our projects are run of the river, and very few storage type of hydro that we have. So the Indian transition, it's a huge transition. You must all be aware that 500 gigawatt by 2030, it's not a very easy goal. So like all the stakeholders need to work together. And while it is being claimed that our PLF has been coming down, but suddenly if you see 21, there was a certain rise because there was a rise in demand post-COVID recovery. And now the government is seriously thinking of adding more coal capacity because with 500 gigawatts, more of this capacity will be needed. And this coal will play a much greener role in the coming years. It's not like dirty coal and whatever people call it, but this integration of 500 gigawatt through coal means coal has to do all this greening act. Otherwise, forget about this RTC, round the clock power from renewable 500 gigawatts. And see, energy security, affordability, and environmental friendly means sustainability. These three things are we call it as energy trilemma. But if we see what in the next 20 years, security will be number one then also. It has always been a concern. Then comes the cost and environmental. We always think of that, but if it comes at the cost of energy security, we have to rethink, and we are rethinking today. Then we have our own carbon goals. Market is also evolving along with the technologies. And there are a lot of barriers. I'll discuss some of them, which we need to overcome. So on the coal also, like this is very important for your GDP growth, for renewable push, then for even for the growth of non-regulated sector. So this was a study done long back, 2019. Today, this is being done with 500 gigawatt. This study was with 175 gigawatt. So you see the requirement. If you see here, if you are able to see my cursor, this is the RE, solar plus wind. So in the afternoon, it will be around 108 gigawatt. From morning, minimum is say 28 gigawatt. So coal, mostly this is coal generation. This is the main dispatchable power. So we get this way we have to operate. And there will be many units which will be required to operate on various modes, whether it is low load operation, whether it is ramping. Ramping you need when you are coming down in the afternoon and again in the evening peak. And evening peak, if you see, the demand also rises. So that adds up to the use of this coal generation. While there will be some plants which will be required to run even on 2 shifting, there will be some on weekly shifting mode. Now, what really is flexible operation? See, still there is a lack of understanding in the sector. People still have to understand like what is flexible operation. Very honestly, we had a workshop some 15-20 days back. There also we discussed. And people only think that, okay, minimum load operation or startup, but all these operations, it's flexible operation. Like load following, then it is a significant load following or mild load following, then minimum load operation. Then even if you operate units above 100%, means 105%, just to meet the requirement of the grid, that is also flexible operation. When you shut down the units and keep it under shutdown condition, this is called as extended layup, wet layup or dry layup, whatever you want. Dry layup is here. So if you don't do it, there's a cost. You consume your life and your unit gets affected. When it comes, you lose in terms of your life consumption, in terms of your reliability, in terms of your heat rate, performance. Your auxiliary will consume more power. So all those issues need to be checked. See, test run was only part of, it was a small part that we did. It is not all that you can do and you will get flexible. There are many things which is required to be done. So market drivers, very short, I'll cover. Transitions, renewable transition, this will drive the market, then falling renewable cost. See, any moment of time, a consumer will buy the cheapest power. This is the economic rule. And he'll think about other things later on, even the environment, about emissions. But if you're getting something cheaper in terms of money, you get that first. So renewable cost, it has come even below coal. But people don't consider the cost of this integration. When you take that into account, it will be much more. But this is the one area where the regulators need to work. Then increasing requirements of ancillary services, DSM, AGC. AGC is also driving your flexibility because to meet this AGC, you are running your units on flexible mode. Then your fuel economics is also driving the flexibility. You know, because your non-pithead stations, no matter how efficient it is, it will have to stop, it will have to go under reserve shutdown as it is happening because the cost of coal is too high and you are not into the merit order. You are very low in the merit order. Environmental norms, at times you may be required to reduce your generation or stop your units. Then market mechanisms. There will be one time when the market will start calling the shots and will decide how your units should operate. The impact, base load will be a thing of the past, at least for most of the stations, not all. Then there will be rapid increase in startups, need for load following, minimum load level needs to be reduced because many state gencos and many generators, they say that we won't be able to go below 60% or 70%. But then they don't understand, what they don't understand is if they have to shut down the units and start again, it's much more, many times costlier than actually running on minimum load. I'll show the numbers also. Off design operation means your units were not designed for that, but you'll require to run. Then you need to spend on some refurbishment, on retrofits, plant layup. People, many of the utilities, they are not practicing a proper layup procedure because they are not required to stop the units for long periods. But it will be a very costly thing unless they start investing in your preservation systems. Then operational cost will increase. with flexible operation. Then there is an interrelationship between flexible operation and heat rate. Boiler losses, it's all known. But when you change your load, this losses increase manifold. There are other factors also. Definitely coal is one big factor. Coal quality, the moisture in the coal. Because having moisture, it imposes a huge penalty on your heat rate. Then even on the turbine, your condensate system. So I think some of these things were discussed. I won't repeat. Then flexibility operation on heat rate. These are the parameters: your firing rate, even the health of your mills, the parameter how you optimize it, what airflow ratio that you maintain. End of the day, what kind of combustion that you maintain, even the fineness of your coal that you maintain. All those things influence the spray, the superheated spray that you are putting into your system. You're not operating your burner tail, but you put more spray. That affects your heat rate. Then there are deposits in the boiler and all, so heat transfer is hindered in those areas because it acts as insulation. So even your chemistry practices, your O2 ingress in the system, if you're not controlling it, there we had recommended, even NTPC had this recommendation of installing nitrogen blanketing in the CST tanks, so that your oxygen into your water system gets reduced, because otherwise it has a huge impact. Water wall circulation. Then whether you are operating on your sliding pressure, modified sliding pressure. So sliding pressure operation is very important. I'll show you a curve. What is the effect of operating on sliding pressure and when you are operating on fixed pressure? But there are some issues with sliding pressure on your boiler, especially on your water walls. There are issues like DNB, then heat transfer, even on the health of your tubes. So that is why when you modify it, you need to trade off between fixed and sliding pressure. At times you overfire when you are changing your coal quality, combustion is not happening. And sometimes when you have to increase your load suddenly, you don't know how much coal to feed in. So sometimes you feed in more coal, so you overfire. And that's a wastage, your heat rate actually increases. Then higher flue gas outlet temperature, if you're not able to optimize it. Even air preheater, this is one area where there's a lot of losses in flexible operation, including the air in leakages when you are fluctuating your load conditions. So optimizing things on a fluctuating condition, it's not easy. So you need a very sound operational procedures. Your control system must be up to date. It's not that you have to put something very great, but ensure that it operates even on low load. What happens on low load, many of these control systems, they're not able to operate on base load units because there are no margins left on the actuators and on the control system. And I've seen many of the even OEMs putting in advanced control system on these units, and it's not successful. I can say that in many of this, at least some of the units I know, it's not successful because the system is not meant for taking that advanced control system. It's like, old ambassador car and you put a Mercedes or Rolls-Royce engine, Rolls-Royce control system. It won't become a Rolls-Royce. For that, you have to change, you have to do some retrofit, you have to change some components. How do you define flexibility? Before you start, you must have your KPIs. So KPIs is definitely minimum load, ramp rate, startup. Then how you do measure and how would you quantify? You control only and you manage only what you can measure. What you cannot measure, you won't be able to control and you won't be able to manage. Then one thing, even if this is with respect to the utilities, with respect to the system operators, with respect to the policymakers, all must have the KPIs, all must have their metrics. One metric that we have is the merit order in India, which is based on variable cost. So that also needs a revision. because many times you see that these inefficient plants, they are which are situated in the pit head, they get scheduled over the efficient plants which are in non-pit head, simply because the merit order system is based on variable cost. So we have been telling the regulators to look into this, maybe to put some carbon pricing, because end of the day we all to ensure reduction in emissions. Even compensation mechanism, what I was saying, you don't have your metrics in place. So what to incentivize, what to compensate? So all those utilities really need to work on this. And then I'll show you one thing. There's a system called economic weighted average availability. You know, we have availability factor today based on which even you get your fixed cost. But availability is not the same. It doesn't have the same meaning for everybody. Because when you are ready, when your power is needed most, has a greater value than being available when your power is not needed. So we have devised a KPI. It was discussed a lot in a conference, EPI conference, where all the international utilities were there. Economic weighted availability factor. So all those things needs to be looked into. So coming to combustion. See, combustion optimization, we are all talking about, like, a lot of things have been done, people are doing, but you need to start with combustion optimization. Unfortunately, one measurement, I think I haven't seen any in India, is furnace exit gas temperature. This is the only indication which will indicate what is happening to your furnace, whether your combustion is getting completed before it enters this tube bundle. It must be completed in this zone. Otherwise, it will continue to burn even in the second pass. So this is one area where a lot of work is needed, and people are still not able to do much in this area. Even coal fineness. I'll tell you one very interesting thing. I visited 3 stations in this year, in which I found there was serious flaw in what fineness was being reported and what the actual fineness was. You normally send some laborers or somebody who is not skilled, some unskilled worker to take the samples. Even in your lab, it is done by unskilled workers, and people sit in the office. What actually is being done, you are not aware. And this is the most important parameter for your combustion. Even when your airflow is not maintained, if you put in more air in your mills, then you'll get bad fineness. So that is also important. End of the day, your coal fineness will indicate like what proper airflow or another parameters. Mills, there are a lot of parameters which can be discussed even in the whole day. But these I've listed some of these here. And if you want to get the details, you please refer to the book, recipe book on flexible operation. It's available online. You just search that on the net, it is available. All those things are mentioned and discussed in details. Even the experiences of the 12 pilot test runs that we have done. Okay, that I am the author of that book, so you can search and read it. Some of the things in Dadri, I think my other speaker, he mentioned it, but it is under implementation at Dadri, almost completed. Is mill auto scheduler, then auto start of fans. It's actually one thing when you start things on manual, it becomes very difficult how to optimize the number of mills in service. When you are on low load, you need to keep minimum number of mills. Typically, people are more confident with more number of mills than required. They end up having a lean mixture, loading the mills even below 50, below 30% also I have seen. At the end, you are just grinding iron instead of coal, and then you are distorting your airflow, air fuel mixture, and your combustion gets poorer. So actually, you are increasing the probability of your tripping. So how would you optimize airflow, air leakage management? Check all your, this is a big area. People working in the plants, they are well aware of this, what is required to be done in air in leakage management, or your expansion bellows, any leaking points. Then furnace exit gas temperature management. First of all, you need to install this. If you're not having, then you can also do offline measurements. You need to procure instruments for that. O2 measurement. There also it must be a representative sample where you measure, that is very important, and there must be a grid. One measurement should be immediately after the furnace, then at certain points. Just economizer inlet or air filter outlet, that may not give you the accurate results. And you end up actually not optimizing your airflow. Optimizing your mills, keeping your number of mills. In test run, one biggest thing that we did, we reduced the number of mills in service. At 40%, we kept 3 mills with a coal quality of around 3000 GCV. And if the GCV is higher, you may require to run only 2 mills at 40%. So these are some of the things. Some solutions are there. It's recommended. Combustion optimizer. There's online solution, mill auto scheduler, online coal analyzer. This is one very important thing because stations are getting different coal quality. There's wide variation in the coal quality, and that's the biggest challenge today. So if you have a coal online coal analyzer, that will help a lot. Operators will know that what they're getting. They can optimize it. Even your control system, if it has right feeding of your GCV, then the control will be much better. But people are not installing this deliberately, let me tell you bluntly, because it has other repercussions. If somebody tells your coal quality very accurately, then you can have other issues. That is the precise reason why people have not installed it today. But this will be of great help. Then there are solutions which will tell you online PF, means pulverized coal flow measurements. Even there are solutions, I think I have in some of the slides, which will tell you coal flow across the 4 pipes. Because there is one big problem of balancing the 4 coal pipes. When you go to a lower load, you have typically, I'll cover that in the next slide. Then structured APC reduction program, have it in the station, and it has to be gradual. It's not a one-shot action. It has to be continuous, comprehensive, and with the involvement of the plant staff. And there need to be a proper structure for flexible operation in the plant. People have to stay on consistently for some time there. Then on technology, I'll skip this. We categorized units based on, this was way back in 2019. Today, some of these parameters may be required to be revisited. That point of time, we had decided that wherever units are getting low grade coal, means GCV is less than 2800, low volatile material, these units won't be able to run on flexible mode. And so this will only run on base load or maybe 2 shifting. Flexible low load. So this was the criteria. Then certain units on flexible efficiency retrofits. One good thing has happened last week. There was a R&M done in one of the units in NTPC Ramagundam. And they got a huge gain of heat rate of 10%, improvement of heat rate of 10% on a 40-year-old unit. It's a great thing. So do we really need to retire this 25 years old plant? Put up new and investment, and most of these units are happening in the North Pithead. So I think they'll issue a press release today. So you read that. It is one of the best things that I've seen over the years. Then certain units will go on flexible daily start. It's already happening in Tamil Nadu. Many units are starting and stopping daily on a 2 shifting basis. But certain units which are very old means like we closed down Talcher, Badarpur, they'll need to retire. This was decided at that point of time, but all this it will be revisited again. On the efficiency, see, this was a curve which we had put in the CA report in that committee, roadmap for flexible operation. I'll discuss this slide. We had done studies in NTPC stations. We had engaged NG Labrole. And see, these are two units. One was, I'll tell you specifically, it was Farakka and then Dadri. So unit A, if you see unit A on fixed mode, and same if it is on sliding mode. See the efficiency fixed mode here, it is say close to 22, 23%, and it comes down to around 18%. So this is the gain in heat rate that you get if you use this properly. And actually till 55% CRC is already compensating the ISGS units, but not all states are not getting it still. And they haven't even asked their state regulators to compensate them. That is the irony. Because I was working for some of the state regulators, I'd given them numbers, some concept notes. One of the states, even the regulator, I presented to the regulator. They were convinced, but the utilities didn't follow up. So these are the cost numbers. This is due to heat rate. See, different mode of operation if you are at 90% and then you go down till 30%. So this is your additional cost. Say your ECR is 2 rupees. Then you have an additional cost that you incur actually. At 30% it will be 34.6. This is for 200 megawatt and this is for 500 megawatt. Then additional paisa I put for your, this is for load following cost. And then what is interesting is weekly start and daily start. So if you do a daily start, this will be 7.5 paisa additional heat rate. But your additional O&M means your damages cost due to damages maintenance cost will be 257, means more than your ECR. So that is why I say people that even if you go to this level, your total cost is only 40 paisa increase. But if you go till this level, 3 rupees 30 paisa, which is better. So if you are not willing to prepare yourself for any of these level, 40% or 30%, so you have to do this. It's your choice. Similarly, these are numbers of 500 megawatt. See, these numbers are accurate, but this all will get changed. This was long back. This was based on 2017 numbers, and it was based on the data of 10 years data. We had done at 4 units, 2 of the NTPC units and 2 units at the state, one of the state GENCOs. We had analyzed 10 years data, their cost data, their operation data. Then we had identified which cost is due to the flexible operation. We had segregated the fatigue creep cycles, and then these numbers were calculated. This is just to show in terms of ECR, but numbers are separate. So this is the number I'll tell you. This is cost per each event. So typically for 500 megawatt, one significant load following. I'd shown you in second slide what is significant load following. Is 50,000 in INR. Then with this actually is almost negligible. A significant load following is 2.7 lakhs. Each significant load following you make, you incur this cost. You damage your machines this much. And from here it goes on increasing, and when you do a cold start, it is 262 lakhs. That point of time, that is for, and see this number won't be same for every unit, to tell you, because even the solutions won't be same for every unit, because there is nothing like one fit for all solution. It will depend on your unit design, on your vintage, on the way historical operation, how you have operated your units in the past, the coal that you are feeding, the coal quality, and a lot of other parameters. So this is just to show you that it is always better to have operate on this mode and on a low load rather than incurring this cost, and you are not being compensated for this, and neither is somebody even knowing his cost. It's only that I was discussing in one of the directors of a company. He told me that in past few months we have damaged 2 turbine casings, but it's not that they have damaged this immediately. See, all these damages happens over the years. It may take up to 5 years, 7 years, because any damage that you are doing, all these individual damages, they get on accumulated, and it gets accumulated, and before the failure, you'll never know, even the symptoms won't be visible. Only when it is, when there is a failure, you come to know, okay, that this much damage has happened. But there are tools today, condition monitoring tools, which will tell you the real-time damages. And efficiency, this is the one part which I've discussed. So this is the compensation which is already there, is different. And we have asked CRC for these numbers till 40%. And this is from one of the reports of I think CRC. They had put it for discussion, but long back, but they didn't get suitable feedback on this. Because even the numbers, what efficiency loss you are actually happening, people don't come up with these numbers. So prepare it for your own units, and then some studies I'll cover. See, when you want, if you want to do your test run, this is a test procedure available to 50 pages document detail on step by step yourself. Then brief on what we had done in India. Globally, we have done a lot of things with NREL, cost of cycling cost benefit analysis. We did for 200 stations. Then power plant cycling cost. This document is available in the public domain. Just search power plant cycling cost. So we work for a EPRI. We provided this effect of flexible operation on boiler components, theory and practice. There are 3 volumes, and I think 1 volume is available free of cost. Others are paid. You have to purchase it from EPRI. And these are some of the things we are doing in India. This is the past. Again, presently there's aware software going on in Vedanta and on TSPL. These are the pilot locations. Latest one is DVC and DAL. We did with Siemens. So the common learnings that we had is, see, ramp rate also, there's a wide confusion. People talk about 3% ramp rate, but you need to understand what actually ramp rate is. 0 to 100% won't be a average ramp rate. What people in the policy, even the system operators, they understand. From the
how many more minutes you will take? Though it is very interesting going on.
Yeah, see, this I can continue for a whole day, or I can end here also. It's just like
no, please don't end here, but try to share the most important thing, so that we want to have a privilege of asking questions to you. So if you can conclude.
Yes. I think minutes. I think this is done.
Oh, okay.
Okay.
Right. Yeah. Thank you, sir. Thank you so much for great presentation. A lot of information, and we know you have done extensive work on it, both from your previous employer, NTPC, as a power professional with EPRI, and now with Intertek. Definitely, we are privileged to have you here with us in India, because we are thinking a lot about adding renewables, and power plant flexibilization is going to be the requirement. So thank you so much for sharing whole lot of data flawlessly. You shared pilot projects, you shared your ongoing projects, you shared your project which you have done in the past. So definitely these are all very, very informative. And we keep hearing both of you in various events, and definitely we will ask questions. But I personally feel flexibilization is a complex subject. And it's again, flexibilization is a journey. I mean, it is not the one you do the modification and you fit it and forget it. You have to keep on raising your bar as far as O&M is concerned, as far as retrofits are concerned, as far as maintenance is concerned. So the whole lot of things going together will ensure that these plants are flexing and coming to the grid, going out of the grid, as and when it is required to ensure that renewable purchase obligation by Government of India, which is the commitment in COP27 also, though COP27 could not agree on fossil fuel. So as Mr. Kamal said, it is going to be for 2 decades. I feel it is going to be for 4 decades or for 45 years or more than that, because coal, the whole world has a coal which can be burned for another 103 years. And coal is the cheapest, coal is easy to control, coal is simple. So the idea is to make coal as clean and green as possible. And for that, we all are working on it. So thank you, Mr. Sinha, for your great presentation. I will start my questions. I will start with me, and then the attendees and delegates may have some question. They will be writing in the chat box or question and answer box. My first question to Mr. Sinha, which plant is best suited for flexibilization? I asked the same question to Mr. Kamal also, whether subcritical or supercritical, if you have to pick and choose.
Yeah, see, we had categorized based on this. Ideally, if you see supercriticals, they are designed with thin-walled components. So they are very good for your fast ramping. But when it comes to low load operation, it's limited by your Benson point. Otherwise, you lose all your efficiency benefit. And then this changeover from wet to dry mode, it's very challenging. So when it comes to low load operation, then subcritical is more suitable. Otherwise, so, any fast ramp up, if you do on a subcritical drum type boiler, it's complex. There are a lot of damages. It's even more costly.
So in nutshell, you give one prescription. I mean, you are talking both. It is difficult.
No. Yes, Mr. Verma, I'll tell you, because first of all, that is why I showed you the second slide. Because there are many things you need to deliver in the market, and you need to understand what is flexible operation. There cannot be one prescription. You need to know what products, flexibility products are there and what will be required. So there can be 2 shifting. There can be some units providing only ramping, peaking power. There will be some which will be on low load operation. I've shown you the categorization of units. Every unit will not be required to deliver all the services. They cannot. So you have to categorize and then see the suitability. Otherwise, every unit will be like James Bond, providing everything. Anything you do, they are capable of doing everything. It's not. Okay. There's a cost and economics.
Okay. Sir, since, I mean, if you are given an, opportunity to pick and choose, because is declaring that I'm going to be flexible is a choice or it's a compulsion? Because in India, as we know that there are many power plants, and I'm sure the day will come, though today we have state-owned plants, private plants, PSU plants. But when we talk about the perfect energy mix, all the plants should be considered one, and then we have to select which one is going to fulfill which obligation, what KPIs, and which will be the best fit. So if you are to select the plant, which one is to flex, which one is to run continuously, and which one is to be shut down. So how do you do that? On what basis?
See, this is a very good question that you asked. And the other day, 2 days back, we were discussing where CA was there, even the CA chairperson was there. And CA chairperson declared that all the units will be required to flexibilize. It will be a compulsion, not a choice.
Now, and I contested. CA chairman, right?
Yeah, Shamji, he was there. So I contested because I talked very openly. Maybe even if I have to differ. Yes. And I think they must have appreciated it. So no, don't do that, sir. It's an economic cost to the country. End of the day. So there will be still some units which will be base load, no matter what. But some very cheap units like NTPC Singrauli, Korba, they are pitted stations. They are among the cheapest. Correct. So there'll always be a base load capacity. whatever fluctuating load, there will be a base load. Above that, there will be fluctuating power.
Absolutely.
There will be some stations which will be on base load, and you need to identify those stations. No need to invest on them.
Correct. Absolutely.
And and then other things, other plants, like what they're capable of. Like even if you make it mandatory, if they're not capable of, then only thing is they may not be able to run.
Correct. Absolutely.
Every day the regulator will tell them, the system operator will tell them. See, one slide I didn't take up because of paucity of time, and I think
you can show now, sir. If you want, you can show now. You can place your slide and show.
So so how people are getting schedules? I think I have it here somewhere.
Please show.
Yeah, I'll just see if it is. I think, yeah. Anyway, I'll continue the discussion. In the meanwhile, I'm opening my slides.
Yeah. Please.
Yeah. So, system operator will give you schedule, and then the damage will be yours. And there's a safety risk. Yeah, I think I found this slide.
But do you think, Sinha sir, schedule will be applicable for flexing plant also? I don't think schedule has any meaning for flexing plant.
No, schedule will be there. See, schedule, there will be a base schedule, and above that, there will be a balancing schedule, balancing power requirements.
Okay. So
I think I don't have the permission to share. I'm unable to share the permission.
Shriyal, kindly give permission, please.
I have given access, Mr. Sinha. You should be able to share.
Yeah, I think now I got it. Yeah, are you able to see this slide?
Yes, we can see the slide.
So this is a typical schedule I had taken. This is an old slide before COVID. Now condition is worse. I'll maybe try to get something on two shifting, what people are actually doing. So this is the 1 day 96 blocks. See the way that schedule is happening. Ram down 30%, significant load following. And I've shown you the cost numbers, the damage. Again, this way it's happening. And this is unit not supposed to be flexible. Nobody has told them to prepare for flexibility, but this is the schedule they are actually getting. This is low load operation. Again, they're flexing many times, and suddenly this has a huge impact. And there are issues like safety issues, O&M cost under recovery, failure, efficiency loss. They may be earning money on IGC or other things. But see, there were a number of safety incidents, which is people shy away from discussing these things. I think Vijayawada and some other stations, there were 2 or 3 plants which had failures. There was one station where we did some studies. That was a station, I won't name that station. They had bottom as hopper explosion 17 times. 17 times. Luckily, no fatality had happened in all the 3 units. Simply, and we went there, we simply changed the operating procedures. Then they got up and they told, no, this is all flexible operation and we have to prepare for this. So either do it willingly or do it at a huge cost. Choice is yours. But you have to do it. It will be mandatory for those units which are non-pit head, which are at mid-merit or high or low in the merit. So I think this is the answer that you needed, or something, some more clarity. You are not audible, Mr. Verma. I think you are not audible. You need to unmute.
My only request is that as the CEA chairman said, that it's sare ghar ke badal dalunga kind of approach is not correct. The same approach they adopted for FGD, it is a very simple answer for him to give, but it will be a disaster. So my request to you is convey our feelings to the Ministry of Power and the CEA chairman that they should pick and choose. There can be a study that which one can flex, which can work as a base load, and then accordingly the plant owner can be compensated. So this is my request to you.
Yeah, see, there's other side of it. It's not simple. The sector still needs to add capacity, lacks the capacity even to plan. All those study and which units need to be done. The utilities, they're not proactive. They should actually, even they should test and say that what they're capable of. So I don't believe and I don't agree to units who say that we are not able to go below 70%, because they have not maintained their plants and they say it's a flexibility problem. Then what many of these OEMs, they were supposed to demonstrate even lower loads. It is in your contract. If you open that portion, there will be like can of worms coming out. And you say that today I'm not able to go even below 70%. That is not agreeable. Because, and in fact, some stations I visited, 4 of the burners, corner fat burners. One burner tip was simply missing. One was completely choked. Then I told you cannot even run your units efficiently on full load. What to talk about flexible operation? So there are other side of the problem. It's not flexible operation. Certain places, again, R&M. Flexible operation doesn't mean that you don't require to do R&M on the units. So that is also needed.
All right, thank you, sir. I will take some 1 or 2 questions from the question box. There are many questions, but then since we have a time constraint, I will take 1 or 2 questions for both of you to answer. One question is there any TPP in India using online coal analyzer give reference? I'm not sure whether it is relevant for this topic, but if you have information, kindly share.
It is very, very relevant. Online, we try to install, not yet, I'm not aware, but we used a handheld device. Handheld, it gives a result. It's time taking. It's not fast, not instant, but it takes some time. But people have not installed for obvious reasons. But at least you will get, may not be very accurate, but accurate enough to give information to the operators to change his operating regime. But handheld devices I have tested personally in my previous working. Yeah.
All right. Okay. One question to Mr. Kamal Kishore. How near is flexibilization of power plant at 40% minimum load going to be compulsory? Sir, both of you can answer, but I would request Mr. Kamal to answer first.
As if we see the CA draft on the flexibilization, right. So it gives it a 3-year period. They are especially asking that every plant need to go for some sort of study, flexible operation trial runs, and then they need to consult their along with the OEMs or some reputed consultant. They need to carry out the modifications. So after this modification, they have to prepare themselves within the 3 year for flexible operation up to a 40% load.
Sir, but my one question, I mean, CEA giving instruction, MOP giving instruction, why they don't, impanel such capable agencies and get it done on their money as a subsidy, so that the plant owners are benefited. Otherwise, this 3 year, 7 year, 6 year, if the same issue, they may not able to find the agency, they may not able to do the work. So I think these small things can be done by our government also.
Normally,
yes, continue, please. Yeah, go ahead.
If you see the tariff norms, it is a cost plus tariff norms. So heat rate compensation is it compensated to an extent. So everybody is looking that first norms comes, it is get compensated, then it will be action will be initiated according to that. So even NTPC was not going for a flexible operation up to 55% till it was almost made mandatory and properly compensated.
Oh, Sinha. Okay, Sinha, your views.
Yeah, see, I come to this government. I had one of my recommendations when I was in this committee in 2018 from NTPC is to use the clean energy cess to give it to the stations to enable them to be flexible. But somehow, and even the CA had agreed. But that point of time, I don't know what happened in this government. There is already money. So you are collecting clean energy cess, so you should use for clean energy purpose. And flexible operation is a clean energy purpose. Probably they didn't understand. So I tell you, there is a lack of capacity in the policy making. There is lack of capacity even in the OEM, I should say. Say today, name one OEM who is fully competent to make you flexible, except one I know in India. I am not convinced. So you need a lot of capacity. And other thing is, even OEMs and others, they are not stakeholding. You cannot be expert in everything. So we need to collaborate. People are not even collaborating. So it's all piecemeal approach. And to tell you, a lot of costly retrofits are not required. That is my say. I have it in most of my presentation when it's only on flexible operation. Nobody invested a lot in US, even in Europe, if you see. All those companies now they want to invest in India. So first start with changes in your operational procedures. You can achieve a lot. 55 till 55% you don't need to invest even a single penny. Only if investment is required in your capacity building. Other part is today you don't have a single simulator for flexible operation in India. So I've been telling even NTPC is not very proactive today, let me tell you very honestly, on this capacity building. On simulator, at least NTPC should have started with a simulator. Because end of the day, see, on the previous study which we did in NTPC and in the states, there were two incidences. One was one operator did 16 times more damage than the other operator. And both these operators, they were considered to be very good operators. So if you do capacity building and 16 times, if you calculate the money, it's a lot of money. So why not to invest in the capacity building? Because for operating this, we did simulator and we improved a lot when we were operating these units, even today's desk operators than where they operated. But now the philosophy of operation has changed and need specific training. So those things are not there. So that is why the capacity building for all.
Thank you, sir. My last out-of-box question. If the flexibilization is so complex, why to do it? Why not run those plants continuously and use the power for other purposes? We are talking about hydrogen, we are talking about EV. Our country is talking about everything. We can have a thermal storage, we can have a salt, molten salt storage. So why to, because I see there is no reduction in CO2 emission, coal is burning more, and then the fatigue and failures, and I know this is going to continue till the plant is flexing. There is no point going to come in the life of the plant when we feel that yes, no problem, n number of ramp up, ramp down, nothing will happen. So this is going to be a continuous business for companies like us to do the retrofit, to do the tuning and all. So why not use this power for other purposes? Why not some repowering kind of activity? This is my last question and brief answer from both of you, and then we will close it.
Yeah, see, the purpose is to, again, it's chicken or egg. You want this 500 gigawatt of renewable with battery. Again, there's one slide which I show on various options for flexibility. There are many ways. So you can either have batteries and renewable, don't touch this coal, but it comes on the economics. So all those options versus your economic cost. So today, economically, cheapest option is coal for us. Hydro would have been cheaper, but for us, the only option left is the cheapest economic option is coal flexibility. So that is the reason we want it, and we also want this 500 gigawatt. But we are also doing a lot of other things. Time of the day tariff. Then certain like mobility that will also take care of some of this like not RTC power, and then grid codes, then markets. Markets will also enable flexibility by shifting actually the demand. So a lot of things are happening, but it will be needed. Otherwise, tomorrow, if RE is able to manage on its own, then why coal? Stop the coal completely. So either flexibility or stop completely.
Agree with you. Agree with you.
Yeah.
Agree with you. One last question. I think it is of my interest also. There is a Vinod Sharma who is asking, and it is a bit complex subject. Even I could not understand many times. And both of you to answer. In low load situation, how we maintain RGMO for a smooth operation? Kamal sir,
There has
you
been
have
a
to
lot.
answer.
Yeah.
First.
Yes, Sinha, please.
No, please. Please answer. I have been answering all the questions. Yeah.
No, I don't think both will be overlapping.
Okay.
Both cannot be overlapping.
Okay. No, I mean, why? How you say that? Because RGMO is a governing mode of operation, and we are talking about running the plant through the load dispatch centers. So why it is not overlapping?
We need to see that from where to where we need to operate the load. Okay. If you are using our governor providing the turbine, so that will be the complementary thing to the flexible operation.
Okay.
But for an external means, it cannot be overlapping, because there is a ramp rate which we have to maintain. So we have to maintain the ramp rate also. What the minimum load we require to reach is required to reach.
Sinha sahab, your last few words.
See, actually, low load operation, it is possible because that is a different mode of flexible operation. And in any case, primary response, primary, there are three types of reserves that you need to keep: primary, secondary, and then tertiary reserve. Primary is very important, 5%. And that is actually delivered by your throttle valve operation. And there is always a thermal inertia into your system, into your boiler, and you utilize that when you operate your turbine control valves. And that is 5% of your generation, because there was another confusion. 5% of the capacity means when we are in the low load, that would be very high. So we clarified that, I remember, long back in NTPC.
Okay.
So that can be delivered, but problem will be when you are on sliding pressure mode.
Okay.
Your thermal inertia gets reduced significantly. Then it will be really challenging.
Okay. All right. Thank you, sir. Thank you, Mr. Kamal. Thank you, Sinha sahab, for your great presentation, great interaction, thought sharing. It has been a tremendous amount of learning for me. And I'm sure Shriyal also must have been benefited by all those discussions, and my delegates and attendees also. Over to you, Shriyal, for your...
Thank you. Thank you, Mr. Verma, for leading this session. And thank you, Mr. Mundhada and Mr. Sinha, for sharing that detailed presentation and all your insights and perspective with us.